The designation of strong and weak acids has to do with the extensiveness of the reaction with water. We can perhaps understand this idea of strong versus weak by looking at these animations. First, we'll look at hydrochloric acid, HCl, in water. What you see are water molecules, oxygen in red, hydrogen in light blue. And of course, in a real beaker of water, the molecules are touching, but the animator has separated them so we can see what's going on. Let's begin this, and we'll drop in some HCl molecules. Stop it for just a moment. Again, hydrogen is light blue, chlorine is green. And when the HCl molecules encounter water molecules, they transfer a hydrogen. HCl is a strong acid. This reaction is extensive. All of the HCl molecules like to give away their hydrogens to water. And then if we zoom in on what we have at the end of the reaction, on the left we have a chloride ion surrounded by water molecules, and notice the animator has put the hydrogen end, the positive end of the water molecules, up next to the chloride. And on the right we have hydronium, H3O1+, and the negative end of the water molecules surrounding it up next to hydronium. Now let's look at what happens when HF, a weak acid, is added to water. Again, we see an HF molecule with fluorine being green and hydrogen again being light blue, but HF is a weak acid. This is not an extensive reaction. So when the HF molecules encounter water, the hydrogen stays where it started on the fluorine. Occasionally, an HF molecule will transfer a hydrogen to water to give hydronium, but by and large, the primary species left is HF. And again, as HF interacts with water molecules, every once in a while it will transfer a hydrogen, but the hydrogen wants to stay on fluorine. This is not an extensive reaction, and the reactants are what are primarily present at the end.